Hi everyone. We are on our third day of word problems, and so hopefully after today you're going to feel like you got this and we can move on. And so the lesson today is going to have a mix of regular word problems. We're going to have some compound interest problems, so you'll get a good mix of everything that you've done in the last two lessons. Okay, so number one says, you deposit $500 in an account that pays 8% annual interest compounded yearly. So because we're dealing with compound interest, I'm just going to write the formula that we've used before over on the side here and talk about what all the different variables stand for again. Okay, so because it's interest, we're talking about exponential growth. Okay, so your formula looks very similar to your exponential growth formula. The only difference is that instead of 1 plus r, you have this 1 plus r over n. Okay, so remember, r stands for the rate as a decimal, and n stands for the number of times per year that your interest is being compounded. Okay, so in this problem, it's saying that it's being compounded yearly, so that just means that one time per year. So n is going to be 1 in this case. If it had said compounded quarterly, that would be n is 4, because that means 4 times per year, and so on. So then when you see your exponent, n times t, that means again that n, how many times per year is it being compounded, times how long are we talking about? Okay, so how many years are we keeping this money in the bank? So what's kind of nice is because we're compounded yearly, like I said before, n is just 1, and so we don't really need to even worry about this special formula because n being 1 doesn't change the value of r or t. So we're really just using our regular exponential growth formula. Okay, so part A says, what is the account balance after 6 years? So I'm going to start with y equals, remember A is the amount that you start with, your initial amount, which in this case, it says I deposited $500, so I'm starting with 500. And then in my parentheses, I have 1 plus, because it's growth. My rate is 8%, which as a decimal is 0.08. And again, I'm not going to do 0.08 divided by 1 because I'm just going to get 0.08, so there's no reason to write that. And then the exponent is to the 6th power because it's going in for 6 years. Again, it would have been 6 times 1, which doesn't matter, so I'm leaving it 6. All right, so if we take a minute and we plug that into our calculator, make sure you are putting parentheses around the 1 plus 0.08 when you're putting in your calculator, because that whole thing is being raised to the 6th power. Okay, and remember to get the 6th power, we use I call it the caret key, looks like this, and then I type in a 6. Okay, so the answer that you get, and remember it's money, so we want to make sure we stop after the hundredth place or round to the nearest hundredth. We're going to get $793.44. Okay, so pretty good. We started with $500. 6 years later, we're at $793. Pretty good. All right, part B. Suppose you get a 12% annual interest rate. How much more would you have in the account after 6 years? All right, so we're upping the interest rate, which, by the way, 8% and 12% is pretty darn high for a savings account, if that's what we're talking about here. So this is a lot of money. All right, so what's going to change? The only thing that's changing is that my interest rate is 12%. Okay, so if I go back to my formula, I'm still putting in $500, but now I'm going to do 0.12 for 12%, and still after 6 years. So if we type all that in, 500 times 1.12 to the 6th power gives me $986.91. Okay, so the question says, how much more would you have in the account after 6 years? So I'm going to subtract the 2. So I want to find out how much more that would be. All right, so I'm going to have $193.47 more if I keep that in there with a 12% rate. All right, good job, number 2. A newly hatched channel catfish typically weighs about 0.3 of a gram. During the first 6 weeks of life, its growth is approximately exponential, increasing by about 10% each day. Find its weight at the end of 6 weeks. Okay, so this is interesting. We're being told that it is increasing its weight by about 10% each day. So when I need to find how much it weighs at the end of 6 weeks, I have to do a little work here, okay, because I have 2 different units of time. So if we think about this, 6 weeks should really be converted into days since my growth is going by days. Okay, so I have to think, all right, well, how many days are there in 6 weeks? Well, there's 7 days in a week times 6 weeks gives me 42. So my time, when I figure this out, is going to be 42. Okay. One other thing I will mention is that this is growth. So I'm going to write down my growth formula to start. A times 1 plus r to the t power. All right, so here we go. We have this catfish, typically weighing 0.3 of a gram to start, so that's my A value. And it's 1 plus 10%, which is 0.1. And we said our time is 42 days. All right, so I'm going to type this in my calculator. 0.3 times 1.1 to the 42nd power. Man, it's problems like this that I'm very thankful for calculators. All right, now it doesn't say anything about rounding, so we are going to just write our decimal out here and find the weight. This is grams. All right, awesome. Number 3, a population of 20 rabbits is released into a wildlife region. The population triples each year for 5 years. What is the percent of increase each year? Okay, so this is a really good thing to talk about. Tripling. What does that mean? What that means is that our growth rate is unknown, okay? Our growth factor is 3. So this is where I really want to make sure you know the difference between growth rate and growth factor. Okay, so the rate is the percent. The factor is what you get after you add or subtract the percent to or from 1. Okay, so just to kind of clarify, how can I write this? Let's see, let's go down to here, because it's saying in part A, what is the percent of increase each year? So again, we know our growth factor is 3, and so I have to think, all right, well, that came from 1 plus some rate. Okay, 1 plus the rate gives me that B. So, okay, 1 plus what gives me 3? 2. And so this number is considered our percentage. Well, how do I write 2 as a percent? 200%. And so that is the percent of increase each year. Okay, so in this case, again, the growth factor is 3 because that's what B comes out to be when I add 1 and 2, but the growth rate is 2 or 200%. Okay, so it's really important to know the difference between those two things. Okay, so part B says, what is the population after 5 years? All right, so let's use our formula. And you know what? I was just thinking of this. Way back when we talked about how this was the formula for an exponential function, but we could also write it as this. right? So B is the same as 1 plus R. So that might help too to see that, okay, 1 plus R and B are the same. So if I need to know just what R is, that's why I was trying to figure out 1 plus what gives me B. Okay, sorry, side note. So what are we doing here? Population after 5 years. So I'm going to go back and use my formula here. And so what was my initial population? 20 rabbits, right? I know that my growth factor was 3. So I'm just going to go ahead and use that right away. And after 5 years, this is the 5th power. All right, so how many rabbits is that? I'm getting 4,860 rabbits. Can't have part of a rabbit. There we go. Okay, part C. Suppose the rabbit population doubled every year for 5 years. What is the percent of increase and what is the growth factor? Okay, so perfect. We have to figure out the difference again. So let's say percent of increase versus the growth factor. Okay, so here we go. Growth factor meaning B, percent of increase meaning R. All right, so it's saying it's being doubled. So what does doubled mean? It means that the growth factor is 2. What does that mean for the percent? Well, 1 plus R equals the B. So I'm trying to figure out 1 plus what gives me 2. Well, 1 plus 1 is 2. And what's 1 as a percent? 100%. Okay, so again, that's how you would figure out growth factor versus percent of increase. All right. Okay, number 4. There is a relationship between the breathing rate of a cyclist on a racing bike and bicycle speed. Let X represent the speed of the bike in miles per hour, and let Y represent the cyclist's breathing rate in liters of air taken into the lungs per minute. The breathing rate of a cyclist on a racing bike can be modeled by this equation. What is the cyclist's breathing rate if the racing bike is traveling 19 miles per hour? What about 25 miles per hour? All right, so we have a lot of information here, but I know that this is a 2-part question, so I'm going to split this right away down the middle here. So first things first, we know that as the speed increases, so does the air being taken into the lungs, because this number is more than 1, which means it's growth. It's exponential growth. Okay, so it makes sense that we are using that formula. All right, so the first thing I'm going to do is I'm going to rewrite the formula that they gave me, or the equation that they gave me. And so they're saying, okay, what is the cyclist's breathing rate, which again is Y, if they're traveling 19 miles per hour? Okay, so the speed is our X. So I'm going to be plugging in 19 into this equation for X. All right, so let's type this in. We have 6.37 times 1.11 to the 19th power. All right, so that's going to give us 46.2675, and then we are talking about, let's see here, breathing rate in liters of air taken into the lungs per minute. So I'm going to say liters per minute. Okay. So then we're going to repeat that process, but now assuming that the bike is traveling at 25 miles per hour. So 6.37 times 1.11, but now to the 25th power. So So if we type all that in, looks like we're going to get 86.5394 liters per minute. There we go. All right, number 5. The hourly rate of your new job is $5 per hour. You expect a raise of 9% each year. At the end of your first year, you receive your first raise. What will your hourly rate be at the end of your 5th year? Okay, so this is exponential growth because we are getting a raise. So let's start with that. Now you guys are going to see sometimes I use X for my time and sometimes I use T. It doesn't matter. It's honestly whatever I feel like writing at the time, but just know that it always stands for your time in this kind of problem. Okay, so you start with an hourly rate of $5. Yikes, less than minimum wage. Hopefully they get tips or commission on top of that. So then we expect the raise of 9% each year. So 1 plus 9%, which is 0.09. And I'm looking for what is going to be my hourly rate at the end of my 5th year. So to the 5th power. All right, so we type all that in. Oh man, not too much better. 769. Time to find a new job. Okay. Number 6. What is the value of an $8,000 investment after 5 years if it earns 8% annual interest compounded quarterly? All right, so here is our compound interest problem. So I'm going to write this again for you guys. All right, so let's pick out some important numbers to start. So A, the amount that I invest initially, $8,000, right? R is my rate, which in this case is 8%, or 0.08. N, remember N is the number of times per year your interest is compounded. So if it's being compounded quarterly, that means 4 times per year. Okay? And then your T is how long you're keeping the money in the bank, which in this case is 5 years. All right, so now that we have all of our important variables sorted out, we can go ahead and plug it into our formula. So 8,000 times 1 plus 0.08 divided by 4 to the 4 times 5 power. All right, I'm going to simplify this before I type the whole thing in my calculator. So when I do 0.08 divided by 4, I get 0.02, and 1 plus 0.02 is just 1.02. And then 4 times 5 is to the 20th power. So I kind of like to do that just to simplify it a little bit. All right, so let's type this in, and remember it's money, so we're going to take our answer and round it to the nearest hundredth. And I'm getting $11,887.58. All right. Number 7. You bought a car for $18,000. The value of the car will be less each year because of depreciation. The car depreciates or loses value at the rate of 12% per year. Estimate the value of the car after 8 years. All right, so I think this is the first one where it's been exponential decay. So let's go ahead and put our correct formula there. All right, so you bought the car for $18,000. There's your initial value. Our decay rate is 12%, so 1 minus 0.12. And we want to know how much is this car worth after 8 years. All right, so type that in. 1,000. 1 minus 0.12 is 0.88 to the 8th power. And again, it's money, so to the nearest hundred. All right, I'm getting $6,473.42. Wow. It definitely lost quite a bit of value after 8 years, huh? But you guys probably have heard that if you buy a new car, as soon as you drive it off the lot, it's depreciated by a certain amount. So, true story. All right. I'm going to go ahead and move to our final page here. You guys are being amazing, following along. All right, so number 8 says the concentration of aspirin in a person's bloodstream can be modeled by the equation y equals A times 0.8 to the t power, where y represents the concentration of aspirin in a person's bloodstream in milligrams, A represents the amount of aspirin taken, and t represents the number of hours since the medication was taken. Find the amount of aspirin remaining in a person's bloodstream after 2 hours if given a 250 milligram dosage. If the dosage was 750 milligrams, how much aspirin is in their system after 5 hours? Okay, so this sounds like something that you would see someone in the medical field doing for sure. Interesting. All right, so we are talking about exponential decay, and I know that because my b is less than 1, okay? And again, we have 2 parts to the problem. So when the person is given a 250 milligram dosage versus a 750 milligram dosage. Okay, so I'm going to start with my formula here one more time. All right, so they tell me A stands for the amount of aspirin that's taken. So I'm going to start with the 250 milligram dosage. And T is standing for the number of hours since the medication was taken. So this says find the amount of aspirin remaining in a person's bloodstream after 2 hours. So this is to the 2nd power. All right, so we can go ahead and type that in. And it looks like after 2 hours, there's 160 milligrams left in their bloodstream. All right. Now, the second part says if the dosage was 750 milligrams, how much aspirin is in their system after 5 hours? So this is going to change our A value. The amount that was taken was 750 milligrams. It still decays at the same decay factor. And now our time is 5. I want to know how much is left after 5 hours. Okay, so let's see here. Looks like 245.76 milligrams are left. All right, that's pretty interesting. Number 9. A store is having a sale on sweaters. On the first day, the price of a sweater is reduced by 20%. The price will be reduced another 20% each day until the sweater is sold. Denise thinks that on the 5th day of the sale, the sweater will be free. Is she right? Explain. Okay, so this is always an interesting concept. I'm hoping that you're thinking no, because no is the correct answer here. This is really getting at your understanding of what exponential decay is all about, because if you think about it, you have a different percentage of the number every day. And so, you know, let's say your sweater started at $40, okay? So if I were to say what's 20% off of 40, I'd be getting that new price is $32. Well, then if I take that $32 and I take 20% off of that, I'm at $25.60. So I would just keep multiplying by 0.8, right? If it's a 20% discount, you can multiply by 0.8 to get the next sale price. And if I continue to do that, yes, it's going to get lower and lower, but think about what the graph of that would look like. Is it ever going to get to 0? Does an exponential decay function ever reach the x-axis? Does it ever get to 0? No. It gets really close, right? Those decimals get smaller and smaller, but it never actually reaches 0, okay? So I'm going to say no, because each day the cost of the sweater is reduced by 20% of what the cost was the day before. Okay, and I'm going to give you my little example here. For example, all right, so I'm going to say the sweater was $40, right? So day 1, if I take that $40 and I reduce it by 20%, now I'm at $32. Okay, if I take the $32 and I reduce it by 20%, now I'm at $25.60. If I reduce that again by 20%, I'm at $20.48. And I can keep going. Now I'm at $16.38. So what I'm doing, by the way, is I'm just multiplying by 0.8 every single time. So what am I at? 1, 2, 3, 4. Let's go one more time. Times 0.8 is 13. Oops, sorry about that. Is $13.11. Okay, so you can see after 5 days the sweater is not free, and it would work that way for every single price that I use. But I'm never going to get to 0. Okay, so one more thing here. Your graph is just going to keep decreasing. All right, so we have 2 more here. In 2015, you purchase a parcel of land for $8,000. The value of the land depreciates by 4% every year. What will the approximate value of the land be in 2022? All right, so we are talking about, because it's depreciation, exponential decay. All right, so originally the land was $8,000, so there's our A value. 1 minus, my rate is 4%, so 0.04. And 2022, okay, so from 2015 to 2022, that's 7 years, so to the 7th power. And remember, this is money, so we're rounding to the nearest hundredth. So it looks like we're getting $6,011.58. All right, last question. Thank you guys so much for hanging in there. A TV station's local news program has 50,000 viewers. The managers of this station plan to increase the number of viewers by 2% per month. After 2 years, how many viewers should the station have? Okay, so this is another one of those cases where your percentage is given in months, and we're being asked to figure it out after years. So we have to do a little conversion. So we always want to convert to whatever the percent is going by. Okay, so 2% per month means I need to change my time into months. All right, so 2 years is 24 months, so T is going to be 24. All right, and this is exponential growth because we are increasing the number of viewers. All right, so what are we starting with? 50,000 is our initial value here. 1 plus 2%, which is 0.02, and then we said to the 24th power for 24 months. All right, now since these are viewers, I'm going to round to the nearest whole number because we don't want a fraction of a viewer. So we're going to get 80,422 viewers.